Hello, I am David, and I'm showing you guys our project from Big Data Architecture. I took this spring semester of 2017 with Gregory Greenstreet. He is a great teacher. He believes in trial by fire, just kind of show us the concepts and we can learn the actual implementation from documentation. Anyway, we're using it right now and we're on the map. The map has birds on it and we click on a bird and open it. We failed. There was no job application and the link was broken. But the general idea is that a little bird told me, or a dot little bird told dot me, is a website that takes tweets and plots the ones where people are offering jobs on a map, and you can find a job solely based off location. As you just saw, there could be many problems with this. For example, the application can be retracted and we wouldn't know. Maybe you noticed I just displayed a tweet from Chicago while I was in California. This is obviously a problem. Additionally, we do not delete tweets from our database that have been deleted from Twitter, which was required by Twitter. Now we're looking at a job application loaded directly from our MongoDB, which is queried onto our web page here. There is a search on the web page, but it's a pretty simple search. The main reason we have the database is to build the Mapbox map. Now in a moment here, I'll pull back the curtain and show you how things are working behind the scenes with the Mapbox map and AWS. And here we are in Mapbox. After logging in, you get a page to customize what your map looks like, and we chose a black map with blue birds on it. There's a place to upload a file of all of the data you're plotting on the map. We build that file from our database. Speaking of databases, let me show you mine. Here we are SSH'd into an EC2 node. Let's bring up my sharded database. I'm using Docker to make MongoDB run more concurrently on a rather large EC2 instance by making it into 11 nodes, the first being Mongo's 1 being the root node, then 3 config nodes that manage all of the sharded leaves underneath them, and then Mongo's 2 is a duplicate of Mongo's 1. This is a master-slave kind of database, and it is highly available with minimal disk footprint at the cost of durability. Mongo's 1 is used for fetching tweets, while Mongo's 2 is used for the website and pulling data from our database. Each of the nodes has a certain number of processors allocated to it to help with scaling and concurrency. Our website runs on the same EC2 instance with the leftover processors. Anyway, now I've hosted the website. After I came up with a cute name, I decided to use Route 63 on AWS to host the domain, and we use Node to run our website. As you can see, we have a M42X large for our instance, and that's because we're scaling vertically, not horizontally, for really quick setup. This was just an educational project, not for production, so we were able to do things like forget about durability. I'm really happy about what we were able to produce in only maybe 4 days. Getting back into it, I'm going to talk to you about the data collection and storing stuff in our database. First, I'll show you how we fetch stuff from GNIP. The reason why we did this manually was because our resource for bandwidth was shared, and sometimes our neighbors were too noisy and took all the resources and caused a crash, so this would have to be manually restarted, or else we would have to do lots of coding around dealing with other classmates, and that wasn't something we wanted to do. We considered using things like Kafka or maybe just entirely different frameworks like Mesos, or we also considered using Spark with Cassandra instead of Mongo, but this turned out to be a really simple way to get it done. Mongo turned out to work excellently with JSON files, which was nice, and we could strip them pretty well with just some easy written scripts in order to make our Mapbox map. Now all that's left is I'm going to show you adding stuff to the database and watching the database grow a little bit. I think we cleared it earlier this day, but I made this video at least half a year after making these screen captures, so I'm not totally sure why we only had like less than 1 million tweets in the database. Thank you very much for watching and listening. This is one of those projects I'm proud to be a part of and learned a lot from, even though it was just a school project. Thank you.